Here is the Goldengate architecture. Okay, you can see the components of the Goldengate here. Okay. Okay, this is the source database and this is the target database. Okay, and this is the Goldengate software. Okay, here you need to install Goldengate software on the source database server, because Goldengate has to be running on the source database server to capture the source transactions. Okay, you cannot have the extract on an intermediate server or a different server capturing data from a different source database. Okay, and you need to install Goldengate on the target to replicate or to apply the transactions that are captured here to the target database. Okay, so you can typically install Goldengate here on the target database, target server, to replicate the transactions, or you can have it on a different different server. Okay, even pumps are the one which sends the trail files from source to target. It could be on a different server. Okay, let's explore this setup in detail. Here, this is the source database. The transactions are coming into the source database. Okay, the extract, it's a Goldengate process which continuously monitor the source transactions and captures the source transactions and write it into the trail files. Okay, it's a canonical format, okay, which Goldengate process can understand and read. Okay, so first it captures the transactions and creates and writes the records, whatever the captured transactions, into the trail files. You call it as a trail file. Okay, and there is another process. Okay, this is a primary extract which captures the data from source database to the trail files. Okay, this is a secondary extract. Okay, this is a secondary extract which sends these trail files to the target. Okay, that is the purpose of this extract. Of course, you can have the primary extract directly send the capture and directly send the data to the collector. Okay, that is this red arrow mark. Okay, it can directly capture and it can capture and directly send it, or you can have another extract which is called as data pump, which pumps the data from source to target. Okay, so you can have another process which can send the trail files that are captured by primary extract to the target. Okay, here in the target, collector is a process. It's a executable that is running as a service on the target database, on target server. Okay, that collects the data from either extract or data pump, that collects the data and writes into the trail file here. Okay, so these trail files are not exactly the same trail files on the target side. Okay, collector collects the blocks of data from data pump or extract and creates a trail file. That is the purpose of collector on the target side. Okay, and once you have the trail file, that means the trail file contains the transactions. Okay, so whatever the transactions here come into this file, and this file gets transferred, and the trail file on the target has the transactions. Okay, so now the transactions are here. Okay, so replicate is another process on the target server which reads the trail file and applies the transactions to the target database. This is the architecture. Okay, manager is another process. Okay, manager is you can have n number of extracts. You can have n number of extracts extracting data from several tables. For example, you can have table 1, table 2, table 3, and you can create 3 extracts to capture one extract to capture table 1, another extract to capture table 2, and another extract to capture table 3. You can have 3 extracts capturing 3 different tables, but there will be only one manager process which will be just monitoring or managing the extracts and data pumps. Okay, this is the main process. These are sub processes or child processes of the manager process. Okay. Now here you need to have manager on the target server. Okay, so that manages the collector and replicate process. Okay, so this is what is called as change synchronization, which is also known as change data capture. Okay, whatever the changes that are happening, it captures and applies. Okay, it captures the changed data. Okay, let us say your database, you have been using this database for a couple of years. Okay, and now you are trying to set up the Goldengate replication. Okay, the reason is you wanted to reporting users to use reporting users, or the data warehouse developers wanted to use this database instead of directly going to source database. Let us say that is the purpose of this setup. Okay, now you wanted to install Goldengate to replicate the data, but what about the data that is there in the source database for several years? How are you going to apply those data onto the target database before setting up the change synchronization? Okay, when you set up change synchronization, okay, when you set up the Goldengate, it captures the transactions that are coming now on the source database and applies to target. But you have to think about how you need to synchronize the data, the previous data, whatever the data that have been there before you install Goldengate. Okay, that is this process, initial load process. Okay, first you need to synchronize target database with the source database. Okay, move all the data before you set up the change data capture, before you set up the transactional replication. You need to synchronize the target database with the source database. There are several mechanisms. One is a Goldengate provided initial load methodology. Okay, so you can do an initial load, move all the data from here to here. Okay, there are a couple of special extracts and special replicates which does that initial load. Okay, you can use that process to move all the data from here to here and then set up the change replication. Okay, that is one methodology. Okay, another thing is you can take backup of source database and restore it on target database and set up the change replication, which is fine. That is second methodology. Third thing is, for example, you don't want all the tables from source database to target database. Okay, there could be 300 tables on source, and the target for the reporting users, they need some 100 tables. Okay, so in that case you don't need to do a complete backup and restore here. Okay, which would take a lot of time or unnecessary things. So you can do export import. You can export those 100 tables to the target and then set up the change replication or change data capture. Okay, so you can do a couple of things. Let's note it down here. Backup and restore, initial load, export and import. Okay, you have to do one of these three, and then set up the change replication. Okay, so why do you need to do the initial load? Because you need to synchronize the data first before you set up the change replication. Okay, but let us say you are creating the database now. Okay, fresh database, there is no data, you are creating the database, and immediately after creating database you are installing Goldengate replication software. So do you need initial load? No. In that case, there is no data. Why do you need to do initial load? Let us set up the change replication first. I'll show you the basic usage of the Goldengate, just change replication. Okay, and after that I'll show you how to do the initial load and backup and export import, how to fully synchronize the target table. Okay, first I'll show you how the transactions come to the source database, and that will get replicated to the target database using the Goldengate. Okay, so we have installed so far we have installed Goldengate on the source database. I have created ODBC connection. Okay, now I need to add tran data. Okay, before adding tran data, you need to have one full backup taken before you add tran data. Okay, that is must required. Okay, so let's take one full backup. Okay, I have taken one full backup. Now let's add the tran data. Okay, so you might be wondering what the tran data is. Basically, tran data is what tran data is. Goldengate needs supplemental logging. Okay, by default. Okay, one more point I need to mention: the database should be in full recovery mode. Okay, it should be in full recovery mode, not bulk log or simple. Okay, so the log will be generated in the full recovery mode only. Okay, so by default SQL Server won't log all the information for update and delete operations in the transaction log file. Okay, so the Goldengate needs extra information, which is called as supplemental logging for the replicated tables, for the tables that you wanted to replicate. Okay, the Goldengate needs some extra logging. That is why you need to enable the supplemental logging for the tables that you wanted to replicate. Okay, why? Because the updates and deletes won't log enough information for Goldengate to perform. Okay, so that is why you need to add tran data. So you can say add tran data dbo dot whatever dbo dot address or whatever table name. Okay, you can say like this for every table. You can say, or you can put these commands, whatever commands, the add you need to do this for every table. Add tran data dbo address, add tran data for rest of the tables. Okay, let us add it. Okay, so before that we need to log in. So when you say db login source db, you need to give the DSN, the ODBC connection that you created. ODBC connection, it points to the source database. Okay, okay, let's look into the syntax. Okay, user ID, not user. I think I might type on user. Okay, okay, now we successfully logged into the database. Now we can add tran data, because it is going to execute some system stored procedures to enable the tran data. Okay, we will look into it. what it has done. Okay, right now if we look into the jobs, there are no jobs because this is a fresh database and the server is brand new. Okay, there is nothing really. Okay, when you say add tran data to that address, okay, so it said, okay, it enabled the tran data for the address. Okay, so basically what it has done, it enabled the CDC future. SQL Server has CDC future. Okay, SQL Server has native replication. Okay, SQL Server has CDC future. So SQL Server has couple of methods to replicate the data. Okay, so Goldengate uses SQL Server CDC feature for enabling the tran data. Okay, so we'll see why. Okay, let's add tran data to another table. Okay, we created. Actually, it's supposed to create CDC jobs. Okay, so previously I just played with this database, so it created a lot of junk stuff. So let me delete the tran data. Previously I just worked with this server, that's why there are some things left over. So let me clean up those things first before we do. Okay, okay, now let's add the tran data for employee table. Okay, so it added the tran data. Now let's look into the server to see what objects it created. Now you can see it created two jobs, cdc dot the source, the database name underscore capture. Okay, so basically it enabled the cdc on the database. Okay, that is what you need to look into it. Okay, now you see the cdc tables here. Okay, this is the, for every table that we enable the tran data, it will create a table here because CDC, this is CDC feature. Okay, the moment, see, now we just added the tran data, but when we start the extract, it deletes this capture job. Basically what this capture job does is it captures the CDC capture job. The CDC capture job captures the transactions, whatever the update, delete, insert transactions, and writes into this table. Okay, because this is a CDC, the SQL Server native CDC feature that it is using to capture the data. But Goldengate doesn't need the captured data in another table. Okay, it can capture uh, from the transaction logs. Okay, but why it needed the CDC? Because here it can point to a location in the transaction log file. That is why Goldengate needed the CDC feature. Okay, previously in SQL 2005, Goldengate uses the publication or articles. See, Goldengate depends on the replication in SQL Server 2005, but from SQL Server 2008, Goldengate depends on CDC feature. Okay, now what you can analyze, or what you can understand, it enable the CDC feature. Okay, when you say add trend data, that's the moment it go ahead and activate the CDC. Okay, now you can take a look at the sys databases. Now you can see source DB. This is the database that we enable the trend data. Okay, so it went ahead and enabled the CDC. Okay, if you look at the tables, employee table is tracked by CDC. Okay, the more number of tables that you enable the trend data, it is going to put this is tracked by CDC. Okay, so you can see that this is the object ID. Okay, so let us instead of executing add trend data for every table, what I have done, you can put all those add trend data into a file which is called as obey file. Okay, and you can execute this file. When you execute this file, it is going to execute all these commands. Okay, that is the purpose of obey files. Okay, so otherwise you can just keep typing commands one by one, which will take a long time. So what I have done is to put that in obey file. Let's execute the obey file. The obey file path is this is the obey file path. Okay, so in the obey file, first line is to log into the database and add the trend data for every table that we wanted to replicate. So it is adding one by one. Okay, so now let's take a look at the system tables. We manually added trend data for one table, which is EMP. Okay, with obey file we added trend data for many tables. So now if you refresh the system tables, you will see the tables, list of tables that it is capturing. Okay, so now if you execute this command, now you can see department table, filter table, employee table, SQL exec table, whatever the tables that we enable trend data, here it enable is tracked by CDC feature. Okay, so whatever the columns that it is capturing, here you can typically dive into the CDC stuff basically. Okay, whatever the columns that it is capturing, DDL history, all blah 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 stuff is here. Okay, so this capture job, it captures the transactions and writes the data into these tables. Okay, now Goldengate doesn't use full functionality of CDC. It just uses for minimal purpose, just for tracking and for checkpointing purposes. So the moment you say start, okay, first you need to add the trend data, and after that you have to create the extract group. Okay, you have to create the extract, and when you say start the extract, that's the time it is going to delete this job. Because if for example you added the trend data, okay, now let us say this is active database and there are several thousands of transactions are coming into the source database. Okay, now you will really see bunch of records in these tables before you add the before you start the extract. Okay, that is why you may have to quickly add the start the extract groups after adding the tran data. Otherwise you will see the records in these tables, it will get populating like anything. Okay, we added tran data. Now let's go ahead and start the extract. Okay, extract is a process which extracts the data for the tables that we wanted to replicate. Okay, first we added the tran data for them. Now let's go ahead and add the extract. Okay, we need to add primary extract to capture the source transactions. Okay, so I can type commands one by one, or I can put that in a ube file and execute that ube file. Okay, here this is how we add a extract. Okay, so extract will have a name, okay, 8-character name, and extract is, this is the source for that extract, where extract is reading from transaction log. Okay, and you can say begin now. That means when you add, it is not going to start capturing the transactions. Okay, after adding the extract, you need to start it to really capture the transactions. Okay, until that time, when you execute this command, it is going to keep this information in the configuration files. Okay, when you say add, it is going to know that okay, there is extract here. After that, then only you can start it. Okay, so when you start it, that's the time it is going to start capturing the transactions, not the time you add the extract to the Goldengate. Okay, the first line is this is extract, you are saying okay, this is the extract name and from where it is going to capture, and how it is going to capture. Okay, when you say start, that's the time it's going to start capturing. Okay, and next line says where it is going to write the trail file. Okay, extract trail file is, this is the one. Okay, dir dat, in this folder G1. Okay, and after that there is a 6-digit character. Okay, it will start creating the trail files G1 0000001. Sorry, 0. This is the first file that it's going to write. Okay, next, after populating 5 MB of data, after capturing 5 MB of transactions, then it is going to roll over. It is going to create a new sequence number, new file G10001. Okay, and start dumping the transaction into the file. Okay, so this is the trail file limit. You say 5 MB means 5 MB. After that, it is going to create next trail file with a new sequence number and start dumping the transaction into it. Okay, so this command says you are adding the extract file for which extract. Okay, for this extract you are linking this trail file. Okay, basically this is complete information for the extract to capture and write it in the trail file. Okay, the first line says you need to define, and second line says where it is going to write. Okay, that's all pretty much. Like that, you have to specify for every extract. In this demo, I'm going to explain several things. For those examples, I have created several extracts. Okay, so I have put all those extracts into the ube file so that we can run this ube file and create all the extracts. Okay, you can manually run it, or you can run this ube file. So I'm going to run this ube file now to create all the extracts and pumps. Okay, let me explain the pump. Okay, this extract is going to capture the transactions, okay, from the database transaction log and write it into the trail file, into this file. Okay, and pump, corresponding pump, this extract is going to extract the transaction from the employee table. Okay, so where did we say employee table? We have one more file called parameter file. Okay, I'll show you in a moment we have to create a parameter file for every extract, for every process. In fact, for every extract, for every pump and replicate, you need to have a parameter file. In the parameter file, we are going to say what this extract is going to capture. Okay, here it is going to say from where it is going to capture. In the parameter file, it is going to know what tables it is going to capture, how it is going to capture, and all those configuration information. Rest of the detailed information will be in the parameter file. So we need to have a parameter file before we start the extract. Okay, but for adding the extract, we don't need to have parameter file. Okay, so here this is the extract I created for capturing the transaction from EMP table. Okay, and this is the data pump process. This is the data pump group I created to pump the transaction. Sorry, to pump the extract file. Okay, extract trail file for the EMP. Okay, whatever the trail file that it creates, this extract creates, this pump will send the trail file to the target. Okay, now while adding the data pump, I have to give the data pump name. Of course, I have to create the parameter file. I will explain you that later. But these two lines says I'm going to create a data pump name GGPC01G1, but you have to keep the naming conventions consistently, or to make sure you can understand. You can see the naming convention here. I said GGEC01G1. Okay, E stands for extract. Okay, C stands for capture. Okay, so particularly remember E stands for extract. Okay, and the trail file I have named G1. Okay, you can have anything. Here I can say some X1, but you need to later on you need to correlate, or you need to put things together. So if you have consistent name, you can correlate and put things together. Okay, otherwise it will be tough. You need to follow proper naming convention to help you understand. Otherwise you will get lost in the Goldengate. Okay, here if you see, the extract name is GGEC01. For the pump, GGPC01G1. Okay, just P stands for pump. Okay, and here for this extract, the source is extract trail source. Okay, for this extract, the source is not tran log. Okay, here the source is tran log, but here the source is, for the pump, the source is this. This is the source for the pump, because the corresponding pump for this primary extract is replicating this trail file, or moving this trail file to the target. Okay, so you need to specify the trail source G1. So G1 is this one. Okay, now the pump is going to take the extract trail file and send it to the target. Okay, so here you said the source is extract trail file. Okay, that you need to set where the target. Okay, remote trail file. Okay, so here you said remote trail file is this one. Here you said remote, you are adding a remote trail file, but who is going to create the remote trail file? This pump. This pump is going to create the remote trail file. And what is the remote trail file size? Megabytes, 5 MB. Okay, after every 5 MB, it is going to create new file with new sequence. Okay, here I can say G1 to have name, to have consistent namings. Primary extract creates G1 001 002 003 like that. Okay, on the target side you can very well say 01 001 G1 002 like that. Okay, just I wanted to show you that the trail files G1 001 is not the same as G1 001 on the target side. Okay, the data might be the same, but the way it is written, the way the number sequencing numbers inside the record headers, everything in the target trail file is different. That is created, the target trail file is created by the collector. Okay, so you cannot correlate or compare. Okay, G10001 on the source is same as, you might get confused. Okay, so that is why I said 1G. Okay, so G1001 trail file will go as a 1G001 on the target. Okay, it could be 10001 or 10004 something. Okay, that is why I given the different naming convention there. So the pump will take the source trail and creates the target trail. Okay, here I am defining those things. Okay, and also I have to say the parameter file. I will show the parameter file later. Okay, so for the demo I have created several extracts and corresponding pumps. Okay, I put that all those information in the obey file. Let's execute this obey file. Let's create the extracts and pumps. Okay, so here it is saying delete. You can see the delete extract is invalid command because we don't have the extract. So here we are saying delete. That is why it is giving the invalid command, invalid option, but that's fine. But when you are executing just for the demo purpose, I have been trying several things before giving demo. So that's why I added this delete statement here. Otherwise, if you are doing for the first time, and you don't need to have the delete. Okay, but having the delete is not going to harm anything. Okay, so it is complaining several things here. There is no checkpoint, blah blah blah. Basically, we are adding all the pumps and extracts in one shot. Okay, so if you have the extracts, if you have created the extracts and extract started capturing the trail files, then after that you add pumps, then it won't give this error. Okay, this is checkpoint for the extract. Where is the checkpoint for extract? Checkpoint for extract will create only if you start the extract. Okay, that's fine, this error. So close out this obey file. Now let us say info all. Interesting. Extract group doesn't exist. Oh, could not create checkpoint file. Interesting, why it could not create. Maybe we don't have permission to the folder. That is another thing you may have to notice. Let's do one more thing. Let's run this command prompt as administrator. This is one important thing you may have to remember. Open the command prompt with run as administrator in Windows 2008 server. Okay, in 2003 by default it runs as administrator, but 2008 it doesn't. So you have to open as administrator, otherwise you get all kind of irritating things going on. Okay, so it says dir. Oh, okay. Sorry. All right, all right. I got the point. What the? We need to create the Goldengate directories. Okay, so that is the first thing we have to do. So dir pom, dir chk checkpoint file, dir report, dir SQL, dir definitions file, dir process, dir out. There are several Goldengate subdirectories that we have to create. Okay, so we are saying, okay, so I have let's create the checkpoint file in this directory, but where is the directory? Okay, that's the problem. Okay, for that that's it. Create subdirectories. Okay, then it creates these directories. Okay, these are the directories required for storing the several information. Okay, when you say create subdirectories, it created these directories. Okay, let me explain what these directories are meant for. Parameter files. For every extract, pump, replicate, you need to have corresponding parameter file. In the parameter file, you specify what tables that extract should capture. Okay, in the pump parameter file, you will say what trail file that I need to send. Okay, so those parameter files, it's like configuration file for that process, I can say. Okay, so those parameter files should be in this directory. Okay, when the process is running abandoned or stopped for some reason, then it will create a report file. Okay, you need to look into the report file in this directory. Okay, checkpoint file, extracts, pump will create a checkpoint. Okay, so checkpoints are required for extracts. For example, extract is reading a transaction log from 1 to 100, let us say. Okay, after reading 50th record, it abandons, a process gets killed, or something happens to that extract. Okay, process stops, extract process stops. Okay, so it needs to, when you start the extract again, when you restart the extract, it should know where it should start. Okay, so it keeps a marker called as checkpoint to let the process know up to what point it has successfully read and created the trail file. Okay, so for example, let us say extract process read the 50th transaction log and written into the trail file. Okay, after writing the trail file, it will make entry in the checkpoint file. Okay, I read 50th record successfully and I created a trail file. Now I'm reading 51st record. Okay, it read the record, but it was not able to write into the trail file, and in between it just got abandoned. Okay, before writing the 51st record into trail file, it got abandoned. Okay, so now when we restart, it just reads the checkpoint file which is in this directory for that extract. Okay, it reads the checkpoint file and it understands that okay, it successfully processed 50 and it will work from 51st record onwards. Okay, that is the checkpoint thing in the Goldengate. Okay, same thing applies for data pump and replicate. Okay, pump needs to know from where it needs to start capturing from the trail files, and replicate needs to know from where it needs to start reading and apply the transaction to the target database. Okay, checkpoint is required for every process in the sense extract, data pump, and replicate. Okay, there are other processes like manager process and collector process. It may not need the checkpoint files. Okay, but you call them as a process also. Okay, this is the directory where checkpoint files are stored, and process status files. Okay, what the process you call extract as a process or group. Okay, sometimes you call it as a group, sometimes you call it as extract as the process. Okay, group is the checkpoint file, the parameter file, all those things collectively called as a group. Okay, so group is a little different than the process, but you see people use these names as synonyms. Okay, extract group or extract process, but both are same. Okay, so when the process is running, extract process is running, it uses this directory for storing the status of the extract. It is running, stopped. Extract can have several status. Okay, now when you add the extract, okay, it will be in the stopped status first. Okay, and when you run it, it will be in the running status. When it abandons for some reason, it will go into abandoned status. Okay, and there is another one more status I forgot, maybe starting or something. Okay, but these are the important status that you will be predominantly, these are the status you'll be looking at: stop, abandoned, running. Okay, so it keeps the status information in the directory and SQL files, maybe for DDL. SQL Server, Goldengate doesn't support DDL for SQL Server. So there is a workaround, alternative workaround for replicating the DDL for SQL Server. But for Oracle, yes, it pretty much does DDL replication for Oracle. It uses the SQL files in this directory, or you can keep some SQL files in this directory. It's up to you. Definitions file. Why do you need definitions file? Because for example, let us say you have an employee table on the source side and you have employee table on the target side. Okay, but there are 5 columns on the source side, but in the target side you have 5 columns, but the 5 columns on the target side is not in the same order as in the source. Okay, target you see employee, source you see employee ID first, but in the target employee ID is last. Okay, the columns are in a different order. Okay, so in that case you need to create a definition file on the source and put the definition file on the target, so that replicate knows how to read the source and how to map it to the target. Okay, we'll come to know more about the defgen and source definitions in separate video, but this is the directory where you generally keep the source definition file. Okay, the trail files contains the data, but how about the process? How do the process know what is the metadata for the data in the trail files? Okay, that's where the source definition files are. Okay, this is the directory where you generally keep it. Okay, you can keep anywhere, but they have created there are some standard directories. Okay, that it is the important directory. This is the directory where the processor stores the trail files. Okay, this is the important directory. This is the directory where you have the data. Okay, and dir temp folder. This is the folder where the extract creates the swap files. For example, sometimes extract keep reading the transactions from the source database. Okay, and there could be some open transaction or large transaction which contains some 2 gigs of data. Okay, and when extract reads the data, and it reads all the 2 gig transactions into the memory. Okay, if memory is not enough, it has to swap, it has to store it has to swap the data into the disk. This is the directory which uses for page swapping, the data swapping. Okay, so once the transaction is done, when extract completely read the 2 GB transaction, okay, the large transaction. Let us say you have the memory of 1 GB and it keeps another 1 GB in this directory. Once the transaction is done, either commit or rollback, it just deletes that the swap file or 1 GB file in this directory. So it uses this directory for page file purposes, page swap purposes. Okay, very data. I do not know about very data at this time, so I'm not going to explain it anything. So standard out, it is not being used at this time, but we have one directory here. Okay, these are the typical directories that you may be working with. Okay, now we created these directories. So now if I run this obey file, it will add. It will not complain that it could not find the directory. Okay, it started creating the checkpoint files now here. Okay, there data, no, there is no data because we didn't start the process. There definition, okay, this is some jar files. Okay, it looks like it added all the groups. So now let us say info all. Info all means information of all process, so it will list all the processes here. So these are the groups that we added. Okay, so we added 9 extracts and we added 9 pumps. Okay, so now let's go ahead and start the extracts. Okay, before starting the extract, the manager, okay, manager, what the purpose of manager is, it can start the extract. Okay, when the server is started, first manager starts and it will start the child process. These are the child process. Okay, so the manager, when the server starts, when you boot up the server, manager starts and manager starts this process, and if this process gets abandoned, manager can restart this process. Okay, so manager has some extra abilities to manage these sub processes. Okay, manager can start or auto restart these parameters. Okay, and manager can send the report. For example, if any of the child processes have lag, okay, there is some lag here, then manager um, can report, enter the lag information into the event viewer. Okay, so first we have to start the manager. Okay, you can have a manager, you can start the manager, or better, let the Windows service start the manager. Okay, first, you can say start mgr. Okay, there is no manager file. Okay, let's create the parameter files. I have the parameter files that I already created. Let's copy all the parameter files. If this is the first time you are creating, you have to create everything right from scratch. Okay, this is the parameter file for the manager. Okay, let's copy these files here. Okay, now we have parameter files for all the process. Now you can say start mgr. Okay, manager is started, but what, so manager is running under your login. Manager is started under your login. Okay, but if you log out, manager will be stopped. Okay, so that's why you need to have a separate Windows service dedicatively running the manager service. Okay, so now if you say info all, manager is started. Okay, you can see manager is running now. Okay, so but if I close this window or if I log out, then my situation is gone, stop. So for that, let's create a Windows service to, there is a command to, okay, got it, here is the one. Okay, so I'll explain this command in detail now. Okay, so this command install, this command will install the service. It will create a service, Windows service. Now there is previously I created static character. Okay, forget about it. There is no GGS MGR service, okay, Goldengate manager service here. Okay, so now this is going to create the manager's service, okay, and also it is going to add events. Will add the events, any errors, warnings, or informational messages will be logged into the event viewer. So this add events going to log into the event viewer, and this add service will create Windows service. Auto start, that means the Windows service is going to automatically start when the server starts. That's what this auto start means. Okay, so under what user account the service is going to run, and the password. Okay, you cannot run this command in the GGSCA because it is a command. Okay, so you have to run from this directory. So let's exit out, run from here. It said the Goldengate messages installed successfully. The user not exist. Install did not terminate normally. Let us see if it created or not. Okay, it did not. Okay, now it created. See, this is the one. Okay. So it created a service. Basically, there is a Windows command sc, the service name, add service something. So this install executes that sc command, Windows sc command, to create the Windows service. Okay, so now it created a service. Now you can start it. Okay, but okay, now this service is going to run under my account. Okay, typically this should be running under Windows domain account. If you have it from domain ABC, then it should be ABC / some name. Okay, that should have logon service right permissions to execute a service. Okay, so this is just to show you that how we typically run the service. Okay, now we have the manager service up and running. Okay, when you say add install, it will install. Okay, the moment you say start, then the manager service is running. So now the manager is running. You can go and check it out. Okay, so now the manager is running. Okay, so now let's start ggec star. That means this is a wildcard specification. Whichever the group that starts with ggec, it's going to start. So ggec 010 up to 09, 9 groups will be started. Okay, if you want to start individually one by one, then you can say ec01 g1. That's how you have to stay. You can also say like this. For example, if I have a group name ggec01, okay, p1 or some k1, something like that, then to start g1, then you have to say like this. Okay, so now let's take a look at the So ggec01 is stopped. Okay, we do not know why it stopped. There might be some problem, but rest of them are running. Okay, to see why it stopped, you need to take a look at the report directory. Okay, so there are, this is a discard file, dsc, and this is discard file, and rpt is the report file. Okay, these two files are very important for debugging. This is where the error messages or why it abandoned or stopped, the information will be stored here. Okay, now let's take a look at the report file to see what the problem with that. It says could not open the checkpoint file. So why it could not open the checkpoint file? Let's start again and see. Interesting, I have never seen this problem. So let me do some research